assign that.
Modeling and mapping. But before I get started, just to give you an idea, I'll ask, like, for example, and CHIP students, like, when you hear the words mapping and modeling, what comes to your mind?
Mapping and modeling?
Yeah.
Different types of data, like how to interconnect them, and then how to present it to a viewer.
Okay, good. Yeah, the reason I ask you is because honestly, like, before I started, I had no idea what this was. But I just wanted to work in tracks because I heard they're good for data analysts and in healthcare. So, but afterwards, I think now I have a better idea. This is basically the topics we'll go over today. I'll try and give you like an overview of everything because we've covered many things in detail, but I'll just try and give you an idea of what we did. So this is the overall objectives. So modeling and mapping, and like Hanzila said, basically exchanging data. And the other part is, I wasn't sure how to classify it. It's not mapping, it's not modeling. It's basically retrieving unstructured data from Immerse, the key elements that the researcher wants. So this was the other part of the project. So this is an overview of what NC-TRACS does. Basically, they do everything with research, whether it's funding, providing data, analysts, helping research participants, or forming any kind of research collaborations. Basically, everything have to do with research. If you go on the website, you'll see pages of services that they provide. This is just an overview also. Okay, so the first part I'm going to mention is training, because training took about 3 weeks, so I thought it deserves at least one slide. Basically, it's required. This is an overview of the training. That's not even all of them. This is just nothing is classified, right?
No.
Okay. I'm sure you'll catch me somewhere along the way. But yeah, this is just an overview of the training. Some of it is like certifications to access the data, and some of it is how to use the tools and the services there. So I'll just give you a quick overview of the tools that we used briefly. So these are the 2 major ones. So has anyone else that's not NC-TRACS here know what these are?
You might want to give a little bit of overview.
Tanzila, do you know, since you're on the roll right now?
Immerse one. Could you explain, please?
Nothing, no guesses?
Really?
Okay, so basically, they both serve the same purpose, the end result of retrieving data, patient data. It's retrieving in different ways. So first thing is the I2B2. It's has to do with, the physician or investigator enters a query into the system of inclusion-exclusion criteria of the certain set of patients that they want, and then they retrieve the data in the form of aggregates, numbers. That's the key word here. They get numbers and not actual records. So basically, they can use these records or numbers in the research, to figure out like numbers in population. Or if they want to retrieve the data itself, the patient records, then they contact, first they need like IRB approval, and then they can work with a CDW analyst to retrieve this patient cohort. This is an example of the screen. Training, I promise. Nothing classified. And this is just notes I took during training. So this is the main screen. So here's the patient query. Can someone here try and tell me what this patient query is? What kind of patient they're looking for based on this? Anyone online also can try.
Related to diabetes.
What kind of patient do you think based on this?
18 age range.
Yes, exactly. So basically, they're looking for a female patient basically it's these two age ranges. So when they're vertical, it's 4. So basically it can be 18 to 44 if you want to combine it. And then these are the different types of diagnosis with ICD codes. So you can see the detail of the diagnosis, how they're all type 1. One is like uncontrolled, one's controlled, and one's just type 1 diabetes. So these are basically, you're adding them together. And if you add vertical, it's basically this one, or it's a range. And there are much more like functions you can do with exclusion criteria as well. Yeah, so this is just a brief overview. And then in the end, when you search this patient set, it gives you a number on the bottom here, as you can see, 423. So you can use this number for your research, or you can get IRB approval and get the patient set, and then basically use the records. Any questions so far? Okay, so the next one is Immerse. So this one is basically also retrieving patient data, but in this case, it's unstructured data. So you're pulling out the patient notes themselves, and every single detail, like the whole note comes up. So if you type in a word or key terms, every note that has this key term in it comes out. But of course, this one is has more requirements to access because you're dealing with patient records directly. So you have to be an employee of UNC Healthcare. And of course, there are regulations, IRB, and then you have to undergo the training. It's also referred to as the Google of EHR, so to get an idea of what it does. So Immerse has 2 main types of notes, order narrative and non-order narrative. So order narrative basically means it's a note that's attached to an order. So let's say you have a CT scan that's ordered, then there's the report that comes with it. Or if you have a sonogram or an MRI, basically note comes attached to it. And then non-order is basically not attached, so it's like a separate note on its own. So this list is actually very long, but this is just to give you an overview of the kind of notes, progress notes, different types of encounters, consults. So these are how the notes are classified. These are over 100 classifications. This one's over I think 40 something. This is the home screen training also. So it's basically just shows you what it looks like. So here's basically it gives you a number of patients. You enter a term here or set of terms, and you can use more sophisticated syntax if you want. It's in the advanced search. It gives you instructions on how to enter syntax. And then there's term bundles here, which is basically you can enter, breast CT patient this age, and then save it. And so you have this bundle that's saved that you can retrieve later and or share it with your other collaborators. And basically, other things you can get like synonyms. So if you put in one word, it'll give you other words that basically mean the same thing or are searched within the same reference. That's it regarding the screen itself. Any questions about this screen?
What's the, so you are working as an intern, but in terms of accessing Immerse, is it similar now in terms of outside researchers to go through an IFD? How do they get access to Immerse?
So for research access, you will need, every Immerse project requires having an IRB that approves you to look at clinical data before you can access it.
Right. So there isn't a de-identified like IQVIA. So not got it. Go ahead.
Okay, so that's the home screen for Immerse. So it's just to give you an idea of how we're moving along in case you get bored. You can see that something's happening. And then, so the first project is the mapping project. So it had 2 components. One was mapping, like Tanzila says, basically bringing 2 sets of data from different CDMs or common data models together. This one, the UNC-CEW, this is the UNC's own, data model or basically data source. And PicoNet is one that's been made and it's used in several institutions. And it's like a structure, so it classifies all the nodes based on categories, and basically puts them in a way that you can retrieve data easily and it can be recognized by many systems in many different institutions if they use it. But of course, you have to integrate your own data, which NC Tracks did from UNC's data warehouse, and then they had to integrate it into PicoNet. And then every year, they end up updating and modifying and adding more mappings. So the first part was preparing for the update that's going to happen soon. And this update is going to add more values. I think it was mainly prescription, lab values, specimen sources. So that's the first mapping. And the second one was PicoNet to Fire, which these are also completely different CMs. So this one, the point of this one is to help UNC exchange data with external collaborators, because the PicoNet is one. There's a network. There are several of them. I think there's 4 that can exchange data with UNC, but FIRE is used also widely. So this can help exchange data with more institutions nationwide. So to give you an overview of the elements for the CDW PicoNet, this is basically, so this is UNC's values or elements, you want to call it. So values basically from the elements. So they had 188, and then PicoNet was 818, and the mappings happened, or I was able to map 105 of them. So many of them were just, you couldn't map them, or they weren't found in both sets. So the second one, as you can see here, the numbers vary. But for the last one here, only the different things that we used, the ones with the 98, 99% frequency of use, because there were 818 here. So, and basically 87 of them were frequently used. So we just mapped the ones that were frequently used.
Just for clarification, see, if we just take prescription unit, is the way I'm interpreting this is there are 188 fields associated with prescriptions, prescription units in CDW, whereas in PicoNet there are 818 fields associated with prescription
values. Yeah,
values.
Yeah.
They could be discrete
yes.
values, right? And so you try to map those 818 fields to CDW or vice versa. Like, what are the common mappable fields across prescription units?
Yes.
Right?
Yeah. So I mean, I can show you. I have the Excel sheet. I can show it to you if you'd like. You want me to show it to you?
No, but let me just follow up. I'm just curious. So how come we have, I can sense why, but I don't have a clear idea. And you're a doctor, so you can explain to me. How come we have that many more prescription unit fields in PicoNet? Is it because they're accommodating redundant fields across different sites? So different sites have different ways of describing the prescription elements. That's why it's so large. Because CDW was just created for UNC, whereas PicoNet, by design, has to accommodate many sites.
Yes.
Is that the reason?
Yeah, that's the reason also. And also many things is, it's basically regarding the values itself, the units, they're much more detailed than the ones that UNC. I can show you, they're broken down more, they're more detailed, but UNC, because they put the ones that they use frequently. But PicoNet gives you everything that you can ever encounter. So that's why many that you'll never encounter in UNC are available in PicoNet, just to make sure that they.
And that's all part of the CEM.
Yes.
Metadata description for all of the units. Okay. Maybe you could show me a few PicoNet elements that help me understand.
Yeah.
What level of granularity?
Yeah, sure. Here, I just want to show you, this is specimen source. It's just an example. I just took a screenshot of a small sample, so give an overview. So this is the UNC value, and this is the mapping from PicoNet. And this is just notes I added regarding the mapping. So you can see some of them. The thing is that some of the values that UNC set are actually, they're a bit inaccurate. So for example, other means basically it's not there, doesn't exist. So for this one, for example, polyps, they say they specify it as a specimen source, but it's not. It's actually pathology.
Yeah.
You see, so some things like that we just named it correctly. And in this case, they put tissue and biopsy together, even though they're different, because tissue is also broken down, like in PicoNet, it's more detailed, deep tissue, soft tissue, not just this way. And yeah, so it's like superficial, soft, deep, and the biopsy is fine needle aspiration. So it's some are just grouped together and they don't belong together. And this one, genital and vaginal, doesn't exist this way. Yeah. It can be either this cervix or this genital. These are separate values; they're not together. Yeah. So that's the kind of mapping that had to go into it. Some of them were incorrect. That this doesn't exist. This value. Yeah, this is just the structure of PicoNet identifiers. So this shows you, tables here, each one on the right side for PicoNet tables. The demographic is considered a table, vital is considered a table, and here they name each one. Like for example, each blue term is a resource. So that's how they classify them. Yeah. So basically, we have to map these tables to these resources. And this is just an example of, so this is the table you're asking about, PicoNet from the online source. So this is the table. Encounter, for example, I just picked a random part to show you. And these are the elements here. So admit time, discharge date, and discharge time. So the way you map, basically you put the table name, encounter with resource name, encounter. And then afterwards you have to go down this list and see which one of these actually goes with, admit time, discharge date. So to get an idea of what these are, I go through the guidance, descriptions, definitions, because sometimes I would think it's one thing, it turns out to be totally different. So these definitions would help. And then, so all three of these fell into period here. And then as you can see here, the description, start and time of encounter. And then afterwards, I go, I basically click on this one and then open the field, and there will be another element and other values to like start or discharge date and discharge time. It will be more of a granular level. But yeah, I mean, the thing is that you have to be cautious because, like there's period here, there's period here, there's period here. So you can easily get confused if you don't look at these definitions, because this is like the time of status, like specific status. This was the time of encounter. So they're very detailed.
Yeah. So one suggestion for finalizing the slide deck before you submit, I would really appreciate if you put the source information where you got these tables from, because just a good practice in terms of citation, but also just anyone else who wants to follow up on these content. If you could put the URL or the doc ID, I don't know, whatever unique way to identify each of these sources, put that in either here in this slide, or you could create like a separate slide of references and put that.
Okay. Yeah. Okay. So, and this is how our tables look like. So this is what I made at Tracks during the project itself. So this is the PicoNet table we saw, the one that was on the left. So this is the table element here. And then starting from, from resource here to the right, that's how to the granular, the level that I went down to. So all the way to, string, ID, all these things. So we start with the resource, and then you have an element, then you have another like element below it. And then as you can see here, you have date, time, so it gets more specific. And here I just added the URL that you can see what actually looks like structured. Any questions about this? Or? Okay, so this is the overview of the mapping, and then the second part of like the projects. This one was a bit different than the others. So for this one, it's basically So this investigator, they wanted a patient cohort, and then they designed a phenotype, triple story phenotype, that would help extract a certain set of patients. So it's like a query basically. So we're looking for patients that, in this case, index date is date of surgery, and then so based on the index date, these patients, it's about the chronic opioid use. So new chronic opioid users. So looking for patients that basically opioid use within 30 days or within the index date. So in this case, all these are yeses. So you want all these. So yes means basically because you're thinking that they took the opioid because of the surgery or the procedure. And then the other one is basically if it's longer or more than 30 days before, then you don't want this patient in your set. And then afterwards, it's 90 to 180 days after index. So once it extends this far, then you're suspecting that he's a chronic opioid user because he should not have prescriptions this long after procedures. And if they do, you want to make sure that they haven't had a new procedure or there is no reason for that. So that's basically the kind of patients that they were trying to extract from this, from the EHR basically.
So this is not necessarily at this level mapping issue. It's more of a data discovery and data extraction challenge, right? And so this came across, I'm assuming, as part of a larger project. So when you call it triple store phenotype, why do you call it triple store phenotype? Is there like a standard thing that uses?
I mean, the triple store itself, it's just it's when you form like a network of objects to to extract at once. So all these are not connected. They're not the same. They're not the same thing.
Sure.
So you have like the surgery, the date, and then you have the opioid use, and you have all these together. So you put them all, you basically tie them together. That's what the triple store is.
Yeah.
And then you try and extract patients that have these connections based on this network. Okay, so the point of this project, at least my task, was to validate that this phenotype was correct. So they extracted the correct patients. So we had about 30 patients, and then I went through every patient on Epic, and then looked through the chart and made sure that all these things were correct and were present in the patient set. So an overview of the findings was that the phenotype itself was correct. So the patients that you actually asked for, you got them, but the problem was not with the phenotype, it was with the data of the patients. One thing was that the CPT codes, so they used the codes for surgeries, which is like a couple hundred codes.
Yeah.
But the thing is that it wasn't surgeries only, it was procedures. So this can be like casting, blood draws. These aren't surgeries, but they're still classified under the CPT code that was entered. So you had patients who just had blood draws, renal punctures, all these things in the data. But it wasn't the phenotype's fault because phenotype said, I want this set, and they got this set. So it was a problem with the entry of data or the code used.
Well, what do you have used for procedures?
Surgeries.
You just put it in the notes somewhere? How would you describe the procedures? Besides, when they have casting versus actually surgery, how would you differentiate from CPT?
How? Because I look at the date, the index dates, and then I would see the procedure on this day because that's considered their procedure. And then I would look through all their notes and then see, okay, what procedure was there. And then you could see the codes on there, and you could see the procedures also. But they're not classified as procedures. You could just read their progress note or their assessment and plan. You could see what happened that day. So then you could, I could determine by that this was the casting, just blood draw. And then you could look at their labs for that day. You look at, all their, basically everything through Epic. I looked through like surgeries through Epic. I looked through everywhere, just make sure that there's nothing I'm missing. And then in the end, I'll just basically figure out on that day what happened. And then you would see that it's either casting or blood draw or something that's not like a surgical procedure. Yeah, so that was the first finding. The second one was the entry of data into the patient's records. Sometimes there'd be like notes attached with like prior history of chronic pain, like arthritis. So they would have the opioid use. but it wasn't actually entered there, so we could not identify that there was actually chronic use. So we thought they were new because the attached notes were not actually entered into the patient's record itself. So the data was not extracted. It was supposed to be placed into the like path medical history, I think, but it wasn't. So this was another problem we have. So it was mainly data entry and codes rather than the phenotype itself.
Are you doing similar projects for other these types of data abstraction, extraction going on for other projects?
Yeah, I think one thing we actually learned through some of the work Nessim did and some of the other interns is that we are pulling the data we expect to when we pull it from the CDW, but sometimes it doesn't actually maybe represent what people really intended. So we've actually implemented a data validation process in which the analysts do a couple chart reviews to catch things like this as part of our standard practice.
Right, that's what I was getting at. I think over time you can develop a standard practice and validations to make sure that you pull the data properly in the first place before you go in and do the abstraction.
This is good. Go for it. Yeah.
Yeah, so that was like the other second sub-project. And then the other project, or the second big one after the mapping, was the MERS project. And for this one, just to give an overview, give an overview, is the point of all this is, of the MERS project, is to have these columns that show like types of records that contain this data. So let's say, we're thinking of like adding labs, imaging, progress note. So because the ones we have right now, this is not even ours. We only have one column. Did they change since then? I'm not sure.
Yes, but you go ahead with the way you do it.
Okay, so since I was there, it was only one column, so everything came up at once. So it was hard to extract the kind of data that you wanted for the patients, and it would be like hundreds of thousands sometimes. So sometimes the investigator would have to go through the notes and try and figure out which ones actually fall within the same category of the research. So the point was going through the notes, the note types, and trying to classify them into categories so that they can be lined up into columns rather than just one.
What are the column headings there? I can't see.
Sorry. It's Carol. I'm guessing this is their medical records system. And then radiology and pathology. Okay. So this is actually it's not that bad because these you can narrow them down rather than just have epic. So the way we worked on them trying to narrow down the categories is using through all these processes. So we looked at the order narrative nodes, which are basically the nodes that have orders attached to them, and the non-order narrative ones without orders attached to them, or the separate nodes. And then we did some interviews with investigators to try and figure out their thought process and how they conduct their research, or the experiences with the MERS basically. And the other one, we extracted search terms from Solr, which is basically, it's like when you go on Google or something, then you extracted all the entries that the providers had, or investigators had, to give you an idea of the most frequent searches that they do. So you can narrow it down. So for the order narrative nodes, basically each one of these is a note type. So you can tell how many notes for each one. So I just went through all these notes and tried to classify them based on grouping. So I put all imaging together, and this is service. So, and this one is basically consults. Yeah, this one's consults, and this one is procedures imaging. So based on this grouping, this is the frequency or number of notes or records. So we're able to figure out that the largest numbers were in imaging and labs. As you can see the difference between them. So we agreed that these could be potential categories in the future. And then the other groups for the order were much less frequent. So we're going to find probably like subcategories for these. But in the back of our minds, we're thinking, okay, so columns, imaging, and labs are two of the major columns that might be useful. Second thing was the search terms. So basically, I went through about 1,500 terms, and then I put them into groups like I did there, and then I found the most frequent, search term type. So I just made categories that went along, and then I started narrowing them down. So people would search more frequently by the name of the disease, with or without. Like you say, you can say strokes. They can use abbreviations, everything. Location of care, so the name of the clinic or the name of the hospital, or inpatient, outpatients, symptoms, diagnostics. A lot of medication names were there. Procedures and anatomical, like you'd say, basically the location of any kind of procedure or any kind of pathology in general. You just say like left arm, or they would say like pelvis. They would say renal, just anatomy.
So, Nessim, you mentioned this, but I didn't quite catch it. So you went through transactions, query logs, to track these terms. Where are these terms coming from?
They're coming from James Champion got them from Solar, which is a server, which is where when you enter search term, search term goes to Solar. I'm guessing extracts, then goes to MERS. I'm not sure how the network works, to be honest, this technical aspect. But he got these from Solar. He has like all the databases of all the searches that go in.
Searching Solar, and who is doing the searches? Is it open to all the?
No, all the investigators that use MERS.
All the investigators that have IRB level access, approved access, they have to this portal. They go and they can do searches. So I can see James basically. These are transaction logs, query transaction logs, where he got these terms from and gave those to you, and then you categorize them.
Yes.
So, your categorization, did you rely on any taxonomies or standard vocabularies, or you just based on your experience of how to categorize them, you just came up with the categories yourself?
No, I came up with the categories based on like groupings. I just grouped them and then I kept narrowing them down more. And if something I didn't recognize, I looked it up to make sure that I knew what it was. But
This is a nice practical set of categories. It makes sense. They're pretty high level, but they're still, they are separate categories. It makes sense. So do you have numbers in terms of how many terms you placed under each of them?
I do that classified.
Yeah, we
I'm telling you.
One thing Nessim found is that sometimes people would search for like a name, and so weren't able to clean that up.
Sure.
Yeah, there are several names. Either
But you did give an overall number of terms that you're playing with. What was the overall number of terms that you start with?
it's 1,500.
1,500.
Yeah, so I'll just go through like each one on Excel and just give it a number, and then that's what I'm doing. This is the non-orders. This is the other type of notes. So these were about 138. So based on these notes, they classified them into these categories also. So encounters, specialties, diagnostics. I tried to find as many similar categories with all of them together, because the end point is putting them all into a verse. So some of them were related, others were a bit different. But this was a non-order narrative. This was the third set, or the third process for the categorization. And this is the interview summary. So we interviewed 4 people. Each one is different. One was a clinical researcher. One was just a PhD researcher. And if you see the kind of studies they did, one was NC Tracks, Sophia. So we asked them about the kind of search they did to make sure we got different types of investigators. Some used the MERS for recruiting, some used it for searching medical devices, some for social determinants, and some used it to determine like symptoms for pathologies or diseases, and quality reports. So each investigator was very different, which was good because it gave us more diverse response. And we asked about their search method. So when you log in, how do you approach the process? What do you start with? Some would start with entering a search term and then try and narrow it down. add another term or use the syntax. Other one would use like enter different like for example different terms for the same disease. Like you'd say like renal cancer, or you can say renal carcinoma, or you can say neoplasm. So the same term across to try and get as much. Other one used key phrases. Other one, the interesting one here was the combined patient name with smart phrases. This was one of the investigators was a physician, and he actually wanted to get patients from his practice. And in his notes, he used to enter some unique terms that would identify his notes only. So he would enter these terms into Immerse when doing research, and this would get him his patients. So he just designed his own way of extracting notes. So he used these unique terms to extract patients. And then some use the term bundles, which basically deform them, and then they save them, and then they would retrieve them later on. And this is just asking about the different types of features that we used. The mosaic one is basically based on the frequency. So the more present the term is, or like higher present, it's darker color. It's through Immerse. So they help them narrow down, okay, this term is more frequent in this patient more than the others, so it's probably more significant. And advanced search 75%. And yeah, so about the categories, we tried to figure out which ones were useful. So we basically designed like a demo table and told them, okay, if you had this in Immerse, would this be useful to you? So we had node type, which is progress node versus the telephone counter, for example. Imaging, labs, and data, and all of them said 100% said yes. And no one had any recommendations for additions. And this is just more technical recommendations that some of the investigators gave us. One investigator wanted to improve the Boolean logic, wanted more advanced syntax, and improve the retrieving, because sometimes it took a long time to retrieve the patient records because they were so numerous. And sorting by age. And this is basically searching nodes by subsection. So if you search, for example, cancer, it can be a diagnosis, it can be history, but you can't tell because it just comes up in Immerse. So being able to search by section would be very helpful. And this is training recommendations. Just the main thing is that some investigators weren't sure about the IRB requirements and what's considered to be a PHI, like the patient basically protected information. That's it. Any questions?
So this part of the project, where it's almost feels like you're doing a usability analysis of Immerse. What motivated that? Was it a partnership thing that you're interested in improving Immerse and making sure that it gets over time more logical, more useful? Yeah. How many overall in terms of user number of users out there for Immerse? Do you guys have any notion how many people are searching? And
I think we have a little, somewhere over 100 people registered, but the active use, I can't remember the numbers, is much lower, because I think it's people need this in pretty specific circumstances. So we had pretty low uptake for the interviews, but I'm glad we did them because we found interesting things from it. And got some good feedback, even if it was
originally Immerse was a project I vaguely remember at University of Michigan, right? Is it still anchored in the University of Michigan?
Yep, and we had a conversation with
Yeah,
David there.
we talked to the guy who created it on the phone to try and figure out, basically trying to understand how we can change the layout itself. Like what kind of access do we have? Because even if we do form those, like to what extent can we actually manipulate the software and change it for it to look this way? Okay, so basically just a quick overview of challenges. Yeah, before I started, like I was telling you in the beginning, I had no idea what the CTM was, what the model looked like, what the structures were. So I had to learn that by looking through them and just reading through all the instructions and the mapping. had to sit with Emily several times to understand how to do it correctly, because I know it's a very delicate process, and if you map something correctly, it can affect patient outcomes basically in the end. And of course, all the guidelines for IRB and patient records, all these things. So understanding all this, laws and rules of working with data was a bit challenging to me. But now basically, I know the importance of mapping, and it gives you, and the importance of all this is that this gives you, this experience gave me like a real world experience of how everything we've learned in all of our classes, basically, like programming databases, working with models, extractions, queries, all these things, how they're really used in the real world. Everything comes together because it's not like each part is segmented. So, and understanding basically all the regulations, working with the patient records and healthcare data, and how to, map and look at each value and element in a way, because you have to understand the type of value, and the definitions, and not just, see a term and just map it together. It's much more delicate than that. And see anything else here? And yeah, of course, what's happening next is mappings are being continued. I'm guessing for Peak, Earth, and Fire, and the categories with Immerse, I'm not sure if they're gonna be better or not. And probably going to use more, like you said, more phenotypes in the future. And other thing I mentioned here was, I know that there's potential to integrate I2V2 with Immerse directly, because now it's not connected. You have to go through an analyst and then get the query and then extract data. It's not one system, so that's also happening in the future. And I think that is it so far. Hopefully I didn't forget anyone important, but thank you.
It's a cornerstone in learning what you got from these experiences. Do you think that this was worth it and think that it's useful?
Yeah, no, I mean, I learned that, I learned things that I didn't pick up in class even until now. All of these like structural details on how to use all the, basically how to work with databases, how to work with elements, and how important it is to, have the same structure and the same format throughout. And, it's like first I thought I'd do more technical work like programming and use tools, stuff like that, which I didn't, which I think is important to have hands-on experience with the data first, because you have to understand what you're working with before you start getting technical, So at first I was a bit disappointed because I wanted to learn programming because I have no programming background.
Sure.
But as I went along and realized, the infrastructure of data and data models, and I think it made more sense to me long-term, how to work with them, what they look like. And so I thought it was a lot of manual labor, everything, all the extractions I did were just by looking through them and just, categorizing them. But I think it was good because that's how we learn best, by doing things.
My impression of what you guys did together with help from Kelly and Emily, I'm sure, and others, James, Bob, seriously, you didn't do one internship, you did 3 internships. And you did, the first internship was on mapping, coordinate data to CDW and Fire. The second internship was on doing the phenotyping triple store. The third internship was on Immerse usability. Each one of them could produce potentially a presentation, a publication, depending on, if you had more time to push them. I can tell you honestly, and we're so fortunate. I'm not just saying that because Kelly is here and Emily is here. This is one of the most fantastic labs that we have, and the learning environment that we have in tracks. And the fact that they invite us, they allow us to work with them, is just, I think it's also, you guys gain from it too, by having our students help you
But, you know, Tanzila is here as an example, working on various things. She's already publishing, presenting in major conferences. I can tell you some of our faculty are not as involved as Tanzila is research-wise. So this is, each of those three projects are groundbreaking in the sense that they are dealing with some very critical informatics challenges and problems. And they will require probably years to conclude, but they're all three of those things. You know, phenotyping, deterministic phenotyping itself is a major area of work in informatics. And I won't even get into usability and search log analysis and search optimization. Immerse is a unique example because you would think there would be more search technologies in this area, and there aren't. And Immerse is emerging, if I can put it this way, almost on its way to become something like InternshipVideo, or maybe even if they aspire to Red Hat, it will become an industry if they really push it. There's a lot of potential for that technology. And what you're doing is you're contributing toward that. And again, especially the Immerse piece, potentially you could become a poster on its own and you could publish because there's a lot of sites that are using Immerse and are interested in it. So I would pick this up and continue working. And importantly for you, because you'll be looking for a job, you'll be looking for career transition. So you need to package it well. You've done good work. Keep working on some of these things. Especially, I would say, again, the usability one has prospect for packaging as a presentation. Maybe next year, Anya, you can create a poster. Anyway, good job. Fantastic.